Hey guys, just wanted to do another video. Hope everybody's healthy with the COVID. So I was thinking about compounding interest and kind of typical questions that we get in the academic world. John put $10 in the bank and they're paying 1% interest. Yeah, how much money is he going to have 3 years from now? That kind of question never really comes up in the real world when you're doing an analysis or a business case. Usually, what you're looking at is historical pricing data. It costs this much for this service. It costs so much for this widget. It was this 3 years ago. What's the estimate for what it costs now? It's referred to as escalation. Inflation, but there is a compounding component to that. So I just wanted to kind of give an example, and I think people will relate to this much more than your typical, I put $10 in the bank, what do I have 5 years from now? And on a side note, bank interest is so low, it's kind of like, who cares what I have 5 years from now? But here's something that makes a little more sense. So I started putting something together here. I said, hey, 5 years ago, you purchased a part, the current price, let's say you went back to the company, you bought this part or this service, what have you, and you needed, and they said, hey, it's $175 per part. And that was 5 years. So I think the first thing somebody would do is like, well, how much did that increase? What are we talking about here, right? So that's an increase of, again, just my easy way of doing it. Where were you? Where are you now? Divided by where you started, and you subtract 1. So that's basically a 17% period escalation. Return, you can even say return. It's not really a return, but so the product escalated in that 5 year period 16.7%. Somebody might call that the period escalation or the holding period. So what does that mean? And I was thinking, if you're giving a presentation to someone and you say, hey, this part went up 16%, they're probably not going to be able to relate to it. When you do percentages, people are thinking annually. They don't think monthly. They don't think quarterly. They always want to relate it to an annual percentage rate. It's just something that is kind of innate in us. So you say, hey, that thing went up 16.7%. That person's one thing is probably gonna mistake you saying that was 16.7% per year, which is pretty ridiculous. So how would you convert this to an annual rate that somebody would understand? So let's clearly identify this is an increase of 16.7% over 5 years. Okay, and I think that's important to understand. But still, people would go, well, what is that annually? So here's what people incorrectly do. They would go, oh, well, that's easy. Equals 16.7% divided by 5 years. There you go. It was escalated 3.3% per year. I don't even have to even do the math. That's wrong. That is incorrect. And I'm going to prove to you why it's incorrect, and it's going to be another lesson. So I started at $150 per year. Okay. So if I take $150, okay, and I multiply it by, and I want to compound 3.3%, right? the first thing you need to understand about that is you go 1 plus. It's called create. You factor. It's a factor. You created it as a factor. So it's 1. You add 1 to the annual or to the percentage rate. In this case, we're saying the annual is 3.3%. 0.033. All right, and then we say, well, that's over a 5-year period. If what we did here was correct, this formula should equal 175 bucks. Well, let me turn it into a formula. 176.43 is wrong. It's not right. So, what's interesting though is this formula can kind of tell you how I can get the right annual rate. So, instead of, you don't just divide, this by the 5 years. Okay. What you do is, same thing. You turn it into a factor. 1 plus the 16.7%, or it would be 0.167. It's just, as you know, Excel is just how it's formatted, right? And you still raise it to the power, but you put it over 1, or you put 1 over it. So it'd be 1 over the number of years. And we said it's 5 years. 5 years. And you probably want to do this. Oddly enough, Excel, if I didn't put the you shouldn't have to put the parens, but for some reason Excel does not do it right. So put the parens. That would be the formula. Oh my God, it's 103.1. Well, that's the factor, guys. So, if you put the number in, that's the factor. Okay, and to turn that factor into a percentage, all you're doing is you taking the factor and you're subtracting 1. Okay, and then you're getting it's 3.1%. Okay, and it's pretty. Let's move it out to some decimal points. So now let's prove our formula. We take the 150, add 1, and if you notice by adding 1, it's already here, right? I don't even need to really add it. This is added to 1, right? But we'll do it. 1 plus this one, or it's simply this one. But it's 1 plus 0.3 1 3 1 for 5 years, right? And now I'm going to have to freaking I was just going to say I have to redo the video, but I see my errors. 0.03. Yeah, guys, I'm not wearing my glasses, but yeah. So now, what in the world? You do have to hit the right key, and the key to surviving in the finance world is to have a joke here. So it's 1 plus 0.03131. Now that should be what I want. 174,999. Obviously, I rounded, so there you go. It's 175. That's the answer. So actually, sorry for that confusion, folks. That was literally me not typing in the decimal point correctly. And I was really thinking in my head, why in the heck? I'm going to have to freaking record this thing because I'm using the free version of this, whatever it's called, Stratocaster or what have you. And of course, that's the other thing I've learned over the years. Use all the free versions. It saves you money if it does the trick. So there you go. So there's a little bit of understanding how the interest rate works. So now that we've figured it out and we've proven that it works, right? Now, when you go, you could say, you know what, that part only increased about 3% per year, 3.131% per year. And that seems somewhat reasonable depending on your industry. Aerospace and defense things seem to get a little bit faster. High tech seems to increase in prices quicker than like a gallon of milk. So obviously, if you're buying a gallon of milk, I think you're looking at this would be really high, right? But if you're buying a high tech part, about 3% per year, I think people would not balk at it, and they understand what you're saying. So I think I'm going to sign off on this video. And then at the next video, I will start messing around with the monthly and the daily and the quarterly interest rates. Again, nobody really does that out in the real world. That's very academic. You get a lot of questions. Well, if the annual interest rate's this, what's the monthly interest rate? If the monthly interest rate's this, what's the annual interest rate? And it's truly not just as easy as dividing it. And, the compounds, right? It compounds monthly. However, I will give you a preview on that. I guess somebody could say it still compounds, and if they say it compounds annually, then you would say, what's the monthly rate? I guess you could divide it. But again, that's not usually what people mean. There's usually, if they want to know the monthly rate, they're saying it compounds monthly. What would the annual interest? What's the equivalent annual interest rate? Anyway, so I'm going to sign off now. If you have any questions on this, but I just want to review real quick. I think I got a minute or so before the free version of this software won't let me record anymore. But what's the key here is, what did we do, right? Let's look at the formula. I got what it was for the total period of years. You divide it by where you ended, or what the new price is to where you started. And you subtract it from 1, that gives you, of course, the percentage rate for the total 5-year period. If you didn't subtract it 1, it would just be a factor. It would be 1.167. But as we noted, when you say something's increased 16%, it has to be annualized. Nobody's going to understand what you're talking about unless if you give somebody a percentage out there in the real world, they are thinking in terms of an annual rate. So you have to turn this into an annual rate, and we determine that by using this formula. And of course, you take your interest rate and you factorize it by adding it to 1. And then you put 1 over the number of years that this period represents. By doing that, you get a factor of 1.031. And of course, like we said, if you subtract 1 from it, there's your annual percentage, 3.13%. And then we proved it by saying, okay, I started at 150. You factorize this, added 1 to the annual percentage rate in this case, because now this is an annual percentage rate. Compounded over 5 years, and bammo. As you can see, we proved it. Remember, and I'm going to say annual percentage rate, just so people realize that this was a conversion, right, from a period return, which of 16.7 works out to be a 3.13% annual percentage rate. So anyway, I'm going to sign off. If you have any questions, just email me. It's on the channel. I'll give you some help. Talk to you later.